Hey guys, this video is about ionic radii, or we can say ionic radius. Now, the ionic radius is the radius of an atom that has either lost or gained an electron. It's going to be measured in picometers. And remember, picometers is extremely small. It's 1 times 10 to the negative 12 meters. So on the metric conversion table, we have deci, centi, milli, micro, nano, then pico. Now, the electron cloud makes up majority of the atom's diameter. So, as you lose electrons, the cloud gets smaller. As you gain electrons, the cloud gets bigger. It's that simple. Now, we will keep metals and nonmetals separately. We're going to later note the two different trend arrows across a period, one for the nonmetals and one for the metals. And later on, in the next coming chapters, we're going to talk about ions a little more in depth. All right, first and foremost, let's start with the metals. Okay, metals tend to form the positive ions, so the ones that lose electrons, because they have a partially filled s orbital. They also have lower ionization energy. Metals tend to lose 1, 2, 3 electrons, which ultimately leads to a decrease in ionic radius. Since electrons make up the electron cloud, they get smaller when they lose electrons. So let's take a look here. Let's look at sodium. Sodium has 11 electrons. Okay, it also has 11 protons. Sodium will lose 1 electron. Therefore, the count of sodium goes down to 10 electrons, leaving 1 extra proton, and that's indicated by the positive sign for the sodium ion. Now, here are our group 1A, 2A, 3A metals, and they're in gray. And you can see that the ion, which is in red, is smaller than the gray. So it does get smaller when it loses an electron. And the trend is very similar to the atomic radius. It does still increase going from top to bottom, and it does decrease going left to right. Now, nonmetals, they're the ones that form a negative ion. Okay, they have partially filled p orbitals. They have a greater ionization energy. They gain 1, 2, 3 electrons, okay, to fill in those half-filled orbitals, which leads into an increase in ionic radius. Okay, since electrons make up the electron cloud, they get larger when they gain electrons. So here, let's look at chlorine. Chlorine has 17 electrons, 17 protons. Chlorine will gain 1 electron. It now has 18 electrons. Okay, it has 17 protons. It has 1 extra electron, and that's going to be indicated in the sign here. So the signs, whether it be a cation or anion, tell us how many electrons lost or gained. Okay, so here we have the nonmetal elements in gray, and then we have our ions in blue. And you can see from top to bottom it increases, and left to right it decreases. Okay, here's all of them put together. All right, and the general trend is increases from top to bottom, and the cations decrease left to right, and anions decrease left to right. And it's very similar to the atomic radius. You want to make a note of that. Okay, here, as you move left to right across the periodic table, the electron cloud shrinks due to the increasing nuclear charge acting on the electrons in the same main energy level. Therefore, cationic and anionic radii decrease across the period. As you move down the periodic table within a group, the outer electrons in both cations and anions are higher energy levels as one reads down a group. Therefore, the ionic radii increases down a group. Now, let's look at this little question I have here. The top set is comparing, okay, these top 4 are comparing an element to its ion. The bottom set are comparing 2 different ions. So take a look at the trend, find each element, and determine if it's larger than the other one. So pause the video. All right, so you can see I have in red the answer. So we have lithium for the first one, F minus for the second, SR for the third, BR minus for the fourth. Now for the first and the bottom set, it's K plus, then CS plus, I minus, and C minus 4. Okay. All right, guys. Well, that's ionic radius. Nothing too difficult. All right, guys. Talk to you later.